I'm going to do a brief introduction to the course. So most of you are familiar, but if you're not familiar with arboriculture, it's the art and science behind tree care and caring for individual or small groups of trees. And as Charlie mentioned, this would be for primarily juniors and seniors. And the lecture that I'm going to give, or the class that I'm going to give, would probably happen about mid-semester for how I teach this, so they'd have had a bunch of information already, and then this is getting them prepped for a final project, just to give you an idea of where this would line up in the semester. Then it's going to follow by, immediately following this, a sample of the lecture and how the different components that I add in and how I approach. And then at the very end, a couple of slides just on a brief explanation of some of the student assessments or assignments that I use, and then my approach to teaching and how I think about it before we get into the question and answer period. So to start, remove or not to remove, assessing tree risk. This is an important part of what you might do as arborists for a variety of levels. And so it's important that we know exactly what we're looking at when we're looking at trees and some of the hazards, risks, or dangers that might be associated. It's important that you take notes and are really paying attention, that you understand what is happening throughout this lecture, because your final project is going to be based on your ability to actually complete a tree risk assessment. And you're going to be given a tree, and somebody else in the class is going to be given the same tree, and you're going to be given an assignment of either trying to keep the tree or trying to have the tree removed, so that you can approach it from two different angles, and then you'll ultimately present your results to the course. So important that you really understand fully what's happening in this lecture. I've got a little bit of audio, so I'm really hoping this works. I did test it out. And so I want you to just listen to this true account of a silver maple, and maybe if somebody can type in if nobody can hear it, so that we can move past that and not sit in silence, okay?
The conflict on our farm was the big maple tree itself. The tree was important to each of us in different ways, but most important to Mother. I think she saw it as a place where we lived. It wasn't that Father didn't like the tree. He did, and he enjoyed the good times we had under it, but he didn't trust the tree. Look, he would say, pointing at the heavy limbs, soft maple trees don't belong on the ridge in the first place. They can't take the windstorms. Well, this one's been taking it for a long time. It dropped a limb on the roof once, only a small one, maybe a bigger one next time. Look, Father would say, counting off the points on his fingers. First of all, it's going to drop a big limb on the house someday. Second, it cuts off the southwest wind from turning the windmill. Third, it makes the house dark. The trouble was that all Father's arguments were based on logic. The rest of us just didn't want him to saw down something that was part of our everyday life.
So here's what's coming up. I don't want you to enter this in the chat box. If you have paper, you should all have paper and pen. I want you to write down, what year did the tree fall? And then what weather condition caused the tree to fall? And at the very end, we're going to hear the rest of this story as to what the ultimate fate of this tree is. And I want to point out a couple of things. The author of this is a true account, talks about they understand the logic of the risk, but they really like the tree, and the tree is providing benefits. And you will often be balanced with that in dealing with the public or dealing with clients, that it's not just a case of we applied the science and the science told us this and we made a decision. There are human things we need to be concerned with in the stories and how people feel about trees. So we need to make sure that we're taking that into account in our assessment. All right, so the importance of assessing trees, I think it's valuable to understand more than just the nice stories we might tell about trees, but some real human impacts here. This is a legal case that happened. Mr. McGinn was driving his car, a branch fell and injured him, and he became a quadriplegic. And the court awarded him $5 million because the city, it turns out, was negligent in failing to inspect their trees. Now, some people choose to focus on the $5 million. I choose to focus on a human life was significantly impacted in a way that could have potentially been prevented by adequate inspection for those trees for risk. So really important here as to why we do this. Another option for those of you that are thinking of becoming climbing arborists and working in trees, here's a story, again, a true account from this book. It was dark, he threw his rope over, didn't properly inspect the tree, felt it catch, clipped in his saddle and began climbing. Moments later, the branch tore off and he went into free fall. You don't want to put yourself in a situation when working in trees where you might cause damage to yourself and also more damage to the tree by not properly assessing and going through these techniques. So this has real world consequences, and it's important to keep those in mind as we go throughout the lecture. So we're going to talk about some of the science, and as scientists, we love triangles. I don't really know why we love triangles, but we sure love triangles. So here's the basic components of risk. A tree with the potential to fail. Now, if you want to be really philosophical about this, I guess everything has the potential to fail. What we're really talking about, which we've looked at, is are there defects present that make this tree more probable to fail under the right environmental conditions? What are the environmental conditions? Well, typically we'd be talking about storms, storm damage, things like that, but it could be construction, could be other things that are happening in the urban environment. So something to look and think about. And then we also have the presence of targets. And the presence of targets are buildings, it's cars, it's people, right? Something the tree might strike that is of interest. So here we have a situation. I want you to think about it. What's the target? Well, the target in this case is this little hut that I happen to be visiting past. The scenario, so what's the potential? Well, if we look over here, it's off picture, but I will tell you my true account, having been here, was that the root plate had been disturbed previously, and there were issues causing this tree to fail. And then we have, what was the environmental condition? Well, this happened to be an avalanche. And you might think, avalanche, well, that's pretty severe. Shouldn't all the trees fail? Well, look at all the trees in the background here that are still standing up. Okay, even this one that's mostly dead. So there are some issues that we might look at where some trees are more probable to fail than other trees. And just as an interesting thing, having actually visited this, just a note of irony, this was the emergency shelter. And if you read the little plaque, it said, do not hide here under storms or because of bears or because of rain. It makes me wonder what emergencies you would use the shelter for. Clearly not avalanches, just something to think about. Tree risk assessment. So what we're going to follow is, and the forms you're going to fill out come from the ISA and their tree risk assessment manual. This is not the only method you can use. There are others. And what we're going to do is use what we've talked about in terms of the science of trees to assess trees, but we're going to use the forms that are put out, in part because this is becoming an industry standard, and it's good to be familiar with these things as you go through, but be aware there are other techniques to use. It's a balance between benefits and risk. If we wanted to be completely risk averse, we would not drive anywhere, we wouldn't have trees, anything, we wouldn't have tall buildings, no one would live in California, there are earthquakes. So clearly there's a certain amount of risk that we're willing to deal with in our lives. And when those benefits outweigh the risks, we choose to keep. When the risks outweigh the benefits, we might choose to remove. Trees are never safe. This surprises people sometimes, but you don't want to tell a client, oh, that tree is perfectly safe. The tree will eventually make a fool of you, and we don't want to set people up to think that there's no risk associated. There's always some, and what we're trying to do is minimize those risks. Owners have a duty of care. Duty of care means that if you own a tree, this could be a city, it could be your private tree, you have a responsibility to maintain that tree to reduce the probability of failure. In terms of what exactly those responsibilities are, usually falls to the courts to decide and are a little bit out of the scope of this class, but we'll talk about that in another lecture just to have some discussion. Limitations on this. You don't have X-ray vision and you can't predict the future. If you can do either of those things, let me know. I'm very interested. But since most of us can't do those things, you don't know what's going to happen. And so all of our assessments come with a timestamp. You might assess a tree and say, this assessment is only good for the next year. Maybe it's 2 years or 5 years, but know that you have a limitation in terms of how much you can really say and how much you can predict. So risk management versus risk assessment. Management is the application of the policies and the procedures. So this might be the urban forester that sets up the policies, or the municipality that sets up the policies and procedures and practices. And assessment is what's important here is the systematic process to identify and analyze and then provide an evaluation. These are all important things of what you'll do as part of your tree assessment. Systematic process is really important here. You don't just give an opinion and say, I think that tree is pretty good. There's a systematic way to go about this. Risk managers typically would be the property owner. This could be a city. You, and as for your assignment, are going to be the assessors or the inspector. And then the arborist is going to be the person or persons doing the actual work. So as part of your assessment, you might say, a few of these branches need to be pruned off, or this tree needs to be cabled, or possibly this tree needs to be removed. The important part is you as the assessor is not the person doing that. That would be something that would be given to someone else. And it makes sense to have these things separated out. So let's look at this. Here we've got the different levels of risk. So we have limited or different levels of risk assessment. We have limited visual assessment. This is the drive-by and the walk-by. You drive by slowly in some cases. Many cities use this for the tree inspector programs, where you might drive through a community and you're looking for really obvious things, large dead branches, maybe fully half of a tree dead or disease and pest. And walk by means you're walking around the tree and you're just looking, but you're not necessarily touching or measuring the tree. Basic assessment, you start measuring. That's what these two women are doing in this picture. They're taking measurements of this tree. They're maybe using some probes and some magnification to look a little bit closer. And then you have more advanced techniques where you're doing excavation, maybe of the soil, maybe you're doing some decay testing, much more invasive in terms of these techniques, and typically more time consuming. Some of the assessment tools you might use for the advanced, this is really cool, tomography. You might look at this and see that, wow, this is really cool. You can basically put these sensors on, you send sound waves or electrical pulses through the tree, and it gives you an idea of exactly how big and where that decay can be. While this sounds like a really great, and why doesn't everybody do this? Well, some of these base levels of the tool is $10,000 to $20,000. And so while it's proved to be very interesting for some research, it isn't always practical for companies of all sizes or for municipalities to use. We have the next level, which is a resistograph. This is a tool, really great. It has a small little needle like drill that gets drilled into the tree at various spots, and it's testing the resistance of the wood. And so you can get a printout and readout. Again, an expensive tool, $8,000 to $10,000 or more, depending upon the exact attachments and additions you get to it. So really an advanced tool, and this follows under that advanced assessment. For the basic assessments, which you're going to be doing in this class, this is going to be more likely your toolkit. You're going to have a D-tape, you're going to have a surveyor's arrow here, so you can probe around and maybe feel for stem girdling roots or decayed wood, measuring tapes, clinometers for height, compasses so you can make sure you're getting the right location of the tree. You might be wondering, what's the hammer for and what's the baseball bat for? Well, you would use one or the other. You can use this to actually sound a tree, which means you lightly bang around the tree and you're listening for hollows. It takes a bit of experience, but instead of $20,000, this hammer is about $295, and the baseball bat I got for free. So, you know, if you have one around, you can use these tools. And yes, professionals do use these, and binoculars can help you see further into the canopy. So these are the types of tools you'll be using for your assignment and in your basic assessment. So probability of failure, what does this mean? So imminent failure, these are the words and terminology you'll use in the form and words and terminology you'll use to make your case. The failure has started and is likely to fail soon, regardless of external load. Probable means that failure under normal environmental conditions. So remember our lecture a few lectures ago, we talked about tree defects, and we'll do a little bit of review, just put it in context. You might have a defect that you'd say, yeah, that might fail under normal conditions. What are normal environmental conditions? Well, for instance, in Nebraska, high winds throughout most of the year are normal. So if a tree cannot deal with high winds, that means that you might have a probable failure. If, however, you're thinking about in Minnesota, where maybe a 2-inch snowstorm is fairly normal in the winter, but if you get a 2-inch snowstorm in Florida, that would be abnormal. And so you wouldn't count that under your normal conditions. So you can see that environmental conditions and weather conditions change based on location. Possible failure means failure is expected during extreme weather events. I'll put an addendum here. We're not necessarily talking about hurricanes or tornadoes, even though those are extreme. We're talking about those maybe once or twice a season, big thunderstorms with heavy winds. The really extreme events like tornadoes tend to take out trees regardless of their condition. And then you have improbable in terms of failure. And this is part of the tree is unlikely to fail under normal conditions as we go through. And then here's a matrix to really help you figure this out. So a couple of things that you're looking at. Here's the likelihood of failure, and then the likelihood of impact. And we're going to go over this very low, medium, and how you assess that. So we might look at these and say, well, it's eminent, but impact is very low, so unlikely. This is going to change the way you approach your management for the tree. So it's important to keep this in mind as you're going through and assessing each of these things. Probability of hitting a target. So you have a high probability, which means that there's basically no protection for the target. It's nearby. If the failure does happen, it's going to hit the target. Medium could hit the target, but not expected. Frequently used areas, but maybe the direction of fall isn't there. So if you think you have a house like this, and we have a tree, there's the tree, and it's leaning this way, it could, I guess, in theory, fall this way under the right conditions, but it's unlikely. It would more likely fall this way. And so you might assess that as, well, it's a medium. Yeah, it's a big tree, could do some damage, but it's unlikely. Low frequency, this was typically, maybe it's just a space that, maybe this is a cabin that's only used certain times of year, and it's not a big thing to consider. Very low target present, but not something, a pretty remote chance of hitting it. And then here's the matrix for this. So you would look at very low, likely, and you use this in combination with the other matrix presented earlier so that you can make a decision. Again, this is part of that systematic process of evaluating trees. Here's an example of a form filled out by a previous student in a different year. And you can see this was one of the better examples. Every part of this form is filled out, boxes ticked. There's information in here. There's even some drawings here to say exactly where on the tree things are located. There's mitigation options. Sometimes this is removal. Sometimes it's pruning, could be other things that could be done. And then there's a reinspection interval of yearly. So this might change based on trees, but these are the types of things you're using the science of trees to understand how to apply this in an assessment for risk. So a quick overview of some defects. We have weak branch attachments, and we already remember we've seen this both in the field as we've walked around outside and in pictures. This is included bark. So bark is rolled in, and here's a picture. This is bark that's in between the wood connection. And that's causing this to be a slightly weaker branch attachment because there is not a wood-to-wood connection here. We can see that this branch here is more likely to fail under particular load. And that load could be wind, could be rain if there's enough rain, or snow, things like that. Could be your rope if you're roping over a branch. We have codominant leaders. So here we have a leader that's the same size as the other leader, roughly in thickness. They originate from the same point. And codominant leaders are of concern because, again, under the right load, if you've got wind swaying back and forth and it's difficult on the tree to deal with that, you might have failure, which we see here. You can see this failed at a codominant leader. That's my hat, so you get a sense of the size of that. It's, as well as with the codominant leader, we see that there's presence of included bark. Here's another tree that failed. We can see the codominant leader was attached with included, not attached, but connected a little bit here with included bark, and this split out. The unfortunate case for both of these trees now is removal. And so if you can catch this before failure has happened, there might be an opportunity to prune or loosen the weight on those branches so that we could potentially save that tree and minimize the risk. But again, we're not completely eliminating the risk. So a reminder of the article you have already read. or should have read if you have not. This went over the strength loss formulas that we covered in class. And it's important when we think about the strength loss formulas that there isn't just one. There are multiple formulas that go out. And there have been new formulas coming out all the time. This is a slightly older paper from 1992 to show sort of an evolution of our thinking about how we address strength loss. And there are new papers coming out. This one's newer from 2017, just looking at the factors that affect the load and the load-bearing capacity of trees. So it's important. This is a science that's constantly changing, and we're learning more. One of the things about the science of these is we're using often static loads, which only partially mimic the dynamic nature of trees and the environment. So it's really important that we keep that in mind. So your first question, I think I mentioned there would be a quiz. There's a quiz through about every lecture, which I know you're used to at this point in the semester. So using the strength loss formula, I want you, and you can type your answer here into the chat window. I want you to calculate what the strength loss is of this particular tree. I've given you all the relevant measurements. And in case you don't remember from the reading, I've told you what big D and little d are. And I've given you the dimensions. This black part in here, this is the decay section of the tree. This is solid wood. So if you want to tell me what the strength loss is, and then assuming a threshold of 33%, where anything 33% or higher is removed, I'll wait for your answers. I'll just give you, I don't want to take up too much time. We have a shorter class period today. So, and yes, you can use your phones as calculators, or if anybody has an actual calculator, you can do that. And I'll wait for an answer or two to trickle in. Just take another sip of coffee to see a little bit more time. All right, I've got some coming in say don't remove. I've got a percent of 66, and okay, we've got 30%. Well, it turns out if we do the math, we end up with a 36. Okay, so it turns out if you do the math and you look at, and here's your tree diameter, you should get about 34.3% if I've done my math correctly. So a few of you got fairly close to that. A few of you a little further away, but that's okay. That happens. We can see that 34% would require removal of this tree based on our 33% threshold. Okay. Yeah, but there's a squirrel's nest. Okay, that's a valid point. We could maybe relocate the squirrel's nest if we were very concerned about squirrels. Some people are. All right. So here we go. Here's your question number 2. So you have tree A and tree B, and here the dark or the black material, this is the decay part, and this open section here and open section here are hollows. So there's no wood left, not even decayed. And the dashed line represents that this is open part of the tree. All else is equal about these trees. Based on our discussion of defects, which tree is less likely to fail under normal weather conditions? And I'll just point out in case my drawing skills aren't great, A has less decay than B. Several people choosing B, okay. Don't be influenced by the herd concept of you have to guess B because everybody's guessing B. But you certainly can. I don't want to steer you one way or the other. A, thanks for playing, Kyle. I appreciate that. All right. So to illustrate the point, here I did a little video for you since we can't meet in person. This is tree A, this is tree B. We're going to apply a load to both of these trees and see how they react. So here's a load coming down. There we go, from above. Tree A, oh, not so good. Let's see how tree B fares. Look at that, tree B withstands the load. Now both of these trees are hollow on the inside, but the important part that we're looking at is that B, as some of you have compromised, or A, excuse me, as some of you noted in your answers, that A is compromised in its outer shell, where B is not compromised in its outer shell, and that provides an additional strength. So we should always be a little more wary about if we have an outer shell compromise. And that's one of the reasons that the formula that you just went through doesn't always work the best, because it doesn't take into account that outer shell. So it's important, there are other formulas and other methods that do take into account a break in the outer shell, and it's important that you use the right assessment in those areas. All right, so thinking back to earlier in the lecture, I want to see a couple of answers here about what two defects that are visible in this particular scenario, and then what is the likelihood of failure based on our assignments here that we've already discussed of this tree. And by this tree, I'm talking about this one right here. And you can type in what two possible defects you see in that tree, and then in the chat window. Yeah, good. I'm seeing some, yep, a tear out from codominance. So yep, absolutely codominant stems we've got here. And we also have some included bark that's there. And we've got one guess of eminent in terms of failure. And that indeed would be the answer here. Eminent failure, mostly because failure has already started and it's likely to continue failing. I've yet to see a tree put itself back together once it started in this realm. So we really are looking at that as a way to go. So we're just going to review some of the others so you feel comfortable actually doing and going through the assignment here. This is a tree. Over here is the full view of the tree, and we can see lots of deadwood, and we see definitely some codominant stems. We see some included bark, and so it's got the defects, and I would call this probable. It hasn't actually started to fail yet, certainly starting to, and is in advanced stages of decline, but I'd expect this to fail under normal conditions. So no problem there. I think this is just a tree you'd probably have to, and in this case, removal is likely your best solution. Here we have a tree. I would label this as possible. As you can see, partly this tree size. It's a very large tree, a little protected around, but it's clearly withstood lots of normal or average conditions based on its age. And we see some problems here. We see included bark and lots of codominant stems, but it's clearly been through many different storms. And so this is possible. Definitely if you had the bigger storms, I think that this would be a tree you'd want to look at. And there might be some pruning mitigation you could do here to remove the weight, or maybe there's some cabling you could do to help. We don't see the actual failure having started yet. So that's an important concept to consider. And here, these are all trees, by the way, that I have gone out and assessed and for various projects. And so these are real assessment cases that had to be made choices on. And here we have a tree that a person called in because we see a lean. And an important thing to assess in leans is, why is it leaning? And this one I deem to be improbable, in part because the lean, as I inspected at the base, there was no lifting of the root plate. In fact, the tree starts and then it starts to lean. It doesn't look like it's bent. There were no broken. I could see no broken or advanced decay throughout anything. There was no evidence of recent disturbance. And it seemed to be that it was actually doing reasonably well here. And this brings up what if you see something like lean, which isn't a tear out, isn't decay? How do you address that? Well, here's another tree. We can see clearly this is in a park and the tree is leaning. I just put this in here to give you an idea of off of 90 degrees. How would you address this lean? Not all leans are the same. If we look closely, We can see evidence of a tree that is trying to recover from a previous wound. We see wound wood here, and we see something going on here, hard to identify. So if we flip around, it's important to walk all the way around. We see, look, some decay, not healing or not sealing over from a previous wound. And we see that here. And then we see a flattening. This is a good indication of potential root problems or stem girdling roots. And there's good evidence. It's hard to tell in the picture, but you can actually see a little bit of movement of the soil denting in here and raising up a little bit here, which means that this tree is shifting. And so I would be very concerned about this tree as we go through and look at and try to think about what might be useful for this tree. What could have happened here? Here's a tree. This actually happened. This is very recent. What could have happened, and could this have been prevented? You might be called out sometimes after the fact to use your tree assessment skills. This car, clearly much harder to drive that to work now with a tree on top of it. Terrible gas mileage. But if we look here, we can see that there's the potential that there were stem girdling roots. We see an indentation, and this is the hole the tree came out of. Note that there's no soil lifting. The roots didn't lift up. This tree snapped off right at that base, right where, and if we looked in the hole, we can see some significant decay. And another indicator is if you look down the whole street, this happens to be a little leaf linden. If you look down the street, there are lots of little leaf lindens throughout, and all of those trees were still standing. And so you might be called in to use your assessment skills after the fact to look at it. Assessing trees are not just for urban forests. This happens to be a group a wildlife conservation group that I helped co-lead in Botswana. And they're looking at a baobab. And here we were measuring and locating baobabs throughout. And we did a condition assessment, a little different form than the ISA form, but we looked at this and look at this amount of damage. So baobabs are an important part of a cultural portion of Botswana, the people of Botswana, and they're also important economically. And so there's some conservation that wants to happen around baobabs. And it turns out that elephants are what cause the majority of damage on baobabs. And elephants are also an important conservation piece of wildlife that really, so there's a conflict between two pieces of wildlife that you want to conserve both, and one is causing damage to the other, and how do you manage that? And so what we did was located 70 different baobabs on this area of the preserve and condition rated them, and we were able to note the conditions that elephants didn't prefer, which happened to be steep, rocky slopes. And doing assessments like this and locating it allowed wildlife managers to then prioritize which baobabs they might protect and where they might seek to improve additions to baobabs in this area. So something to consider, that these assessment techniques can be used in multiple areas. So just take a quick listen here as we finish up on the last little bit of this story.
The big maple tree, which I always thought of as part of the family, was still here to greet me when I returned. And I found it was my turn to look up anxiously when strong southwest winds swayed the maple toward the house. I watched and worried for 10 years after I came back. And then the roar of the wind woke me one night just in time to see the tree fall toward the house. And soon I found myself writing this eulogy. There has been a death in the family. A faithful friend and companion, aged approximately 107, a part of so many lives and so many memories, surrendered to a tornado on July 15th, 1997.
So think of that. I know silver maples get a bad rap, but 1997, and he originally wrote the first part of the story in the 1930s, and it was a tornado. So a really extreme event that takes out, honestly, even trees without significant defect. So really, I think surpasses what most people think of silver maples, and leads to us thinking about really the systematic process is important. And you could hear him talk about the tree in terms of the value and importance it was to a lot of lives. So we can't discount that always, and we need to be considering those as we make our assessments, but also making sure we're balancing that with the risk in human life, clearly. Some final points. First, trees provide benefits and have real meaning to people. Clearly, I think we've covered that and talked about that, and it's important to consider. Trees are dynamic, heterogeneous entities. Sometimes engineers come in and they're like, well, it's just a cylinder, right? No, these things are not homogeneous in their production. And so we need to think of that and remember that trees are dynamic and they're dealing with dynamic forces. Management and assessment and systematic approaches to balance risk are really the important objectives to think about here. Having clear policies and then a clear systematic process to deal with that is very important. Next class, we're going to be outside using the assessment techniques so you get a sense of what it really looks like and how to fill out the form. So you should be prepared for that next time. We'll be outside walking around looking at trees. All right, so that finishes up the class, and I want to give a quick sort of overview of my assessments and approach. I tried to integrate as many of those things that I do in a class that I can, and I know it can be sometimes a little awkward over Zoom to figure out some of those things and the actual way things work. So my classes are typically a mix of discussion and lecture, and sometimes there'll be one full lecture, and then the next class period we mostly discuss what happened or some of the readings. Sometimes it's a mix in a class. Depends upon the topic and how detailed or technical it might be. I try to engage students actively throughout class by asking questions and quiz questions that are graded, but lower stakes, and sometimes they're immediately from what we just talked about or just from the previous lecture to go throughout. In the classroom, I look at both inside and outside the campus to utilize. Remote learning, as we're all getting used to, I think I've been working more and more with some video and doing both synchronous, which is what we're doing, and asynchronous methods where some recorded video, and having students record and send in those as a way to stay engaged, both them with the class and me with the students, I think is an important challenge we don't often discuss. Assessments of student learning. So I don't do exams typically in the upper level courses. We switch into final projects, and this tree assessment final project really brings together all of the things we talk about in arboriculture, the management from pruning and cabling to assessing trees and tree biology to looking at trees for people. And so this is a nice final project that really lets them demonstrate what they've learned throughout the course. In-class and online quizzing. I use online quizzing quite a bit, especially when there's a reading. They take a quiz about the reading so that they're a little more prepared. And weekly writing assignments and questions. And if anybody's interested in this, when we get to discussion point in just a couple of minutes, I'd be happy to talk about that. But every week they write a little 250-word summary of what they've learned, and then they have to ask a question as part of that assignment. And this helps with drawing out some of the quieter students who maybe don't like talking in the middle of class or are a little more hesitant, and it lets them ask anything they want. I usually tell them it should be about trees and arboriculture, but I really open. They can ask anything they want, and I do my best to answer every single question in writing, and I typically bring in a highlight of those questions into the next class. I don't identify the student that asked, I just answer it to the whole class. And the photo-based assignments. Really have gotten into this over the last few years, even before COVID. And here's an example of that. Just to look at tree defects, I give them, here are the defects we've talked about in class. They have to go out and find 5 different trees with 5 different defects. They have to take a picture, draw circles and arrows, and write a paragraph on the back of each one. That was just for the Arlo Guthrie fans in the group, or Alice Restaurants fans. My students don't get it either. It's okay if you didn't understand. The idea here, though, is that they actually go out, find things, take pictures, and submit them. It allows me to see what they're really understanding and allows me to provide feedback. So it's really been great. And this is just one. There's a whole series that I use both in dendrology and arboriculture and urban forestry to get them out really looking at what's happening. And yes, occasionally, only once have I had a student, they're not allowed to use internet images. I once had a student use an internet image, and now I just tell them, yes, I've seen the entire internet at this point. I know what images are on the internet. Don't submit them, right? Quick note on cultural and inclusive perspectives. I was happy to see the GPS Alliance. I do add in the travels that I've had either through the study abroad experiences or just personal travels as I've worked with colleagues around the world really at this point, from Hong Kong and Africa, even to exotic places like Canada, and how they deal with what's going on, to really try and foster, for students that haven't been out, try to foster the idea that different cultures and approaches are important. in the diversity in the classroom and how we approach natural resources. And in every class, at the beginning, middle, and near the end of the class, I talk about student counseling services for students that might be going through any mental health issues, any issues at all. They don't have to tell me. I invite them all, if they have a hard time finding resources, to get in touch with me so I can help them find the right resources. But I realize, especially going forward, things are just can be stressful for students. And I take it takes about 2 to 5 minutes, 3 times a semester, to make sure students are doing well in their own personal health in class. And with that, I think I went a couple minutes over, so I apologize for that. But I'm happy to answer questions as we go.